These two tools that I'm going to talk about today, the single phase ID, the part number on that is SPID, and the three phase ID, the part number on that is TPID. Again, these tools are relatively new. We developed these tools for major investor-owned utilities. They requested a tool to work for their specific requests that they had. And the single phase ID tool here, I've got one here. It works off 18-volt batteries. It can be off any platform. We have it set up for Milwaukee today in this demonstration, but any 18-volt platform will work. The three-phase ID kind of expanded off the single-phase ID concept, where instead of doing one phase, we're doing three phases. We added a little bit more variation to it that you can get any type of an attachment that you may need. So I've got an alligator clamp here. We're going to be using elbows that I have in this cabinet here. You can get ball studs, C-clamps, so you can get an array of different type of accessories as far as attachments for the three-phase ID. The single-phase ID just comes standard with alligator clips, but for today's demonstration, we do have a custom-made elbow that you can use for the single-phase ID. But both of these tools can be used for overhead, underground, any URD or cable station cable installations. So you can positively ID open conductors. Again, positively ID conductors that are grounded on one end. You have the device attached on this end, and also testing for removal of grounds. So that's kind of a new area where especially the three-phase ID has been applied, where it's performing what's called a soft ground check. So this again is a new, to us it's new anyway, where again the utility is using it as a soft ground check just to see if either the cable is grounded, the de-energized cable is grounded, or in this case right here, whenever we're using the tool, whenever you remove the grounds. So that's a real big safety factor in utilities, where if you have to remove grounds, let's say on phase A, and you're looking at the device here and that person removes the grounds. I mean, this can be blocks away, half a mile away, whatever, and they remove that ground. You want to see a positive identification on this tool. So if you're doing it with the single phase ID, you're going to see the pass light go away. If you're doing it on the three-phase ID, you're going to see the corresponding phase light go away. So it's a really good tool for that application. And again, you can use this tool on multiple sets of grounds. So what I mean by that is if I'm, let's say, working in, say, a 6-block area, and 3 blocks away I have one set of grounds, but I want to continue to ID past that 3 block to the 6th block, I don't have to remove my grounds on the 3rd block. So I can leave my grounds attached and continue IDing. So that's a real big safety factor built into these tools, is by, again, leaving the grounds attached. You don't have to lift your grounds every time you move the sender. You can leave the sender here, ID to your first set of grounds, and continue IDing. Some utilities have said that they've actually been able to ID past the 2nd set of grounds. So it's a real big safety factor when you consider, having to move the sender, lift grounds, the coordination. It saves a lot of time, saves a lot of coordination issues. So I'm going to go over real quickly how these tools work. I'll start with the single phase ID. Again, you just have the 2 leads, a red lead and a black lead. This is a polarity device. So in other words, if I'm using the receiver, I'm going to see a pulse going a certain direction based on how I use that receiver. So it is a polarity device. And that's true also with the three-phase ID. It is a polarity device. Again, it uses 2 18-volt batteries, any platform. Simply turn the tool on. You'll see corresponding lights based on if there is continuity or not. And on the single-phase ID, it's called a pass light, a green light, and a fail light, which is a red light. So if I have a pass light, a green light, there is continuity. If there is not any continuity, I get a fail light, a red light. Before you use the tool, you want to test your batteries. We do have a slim 3 milliamp hour battery here, as well as the kind of legacy thicker 3 milliamp hour battery. So this is a lot of weight savings. You know, if you do use these batteries, you can use the 1.5 milliamp hour batteries. Again, this tool is going to run a very long time. We do recommend that whenever you are using the tool, you have at least 2 bars on your battery checks. Most batteries now have a self-check feature where you can just push the button and see how much charge is on the battery. We do recommend at least 2 bars. If it starts getting below 2 bars, you know, it can dissipate the output of this device, so we highly recommend it has at least 2 bars. You know, if it gets below that, just go ahead and swap the batteries out. So that's the single phase ID. The 3-phase ID is very similar. It's a little bit different nomenclature here, whereas, you know, you have a corresponding phase per light. So in other words, on my A phase, I have a red light, my B phase a yellow, my C phase a blue. And making continuity is, again, the pass-fail. It's equivalent to the pass-fail. So in other words, if I have a continuity light on my 3-phase, that's equivalent to the single-phase pass. So there is continuity on the circuit. If I do not have continuity, that means the circuit is open. And these devices are, again, a really good check on the circuit. Basically, if I have this light, I have roughly 5 ohms or less of continuity. So it is a really good check. So again, A phase, B, and C, corresponding continuity lights, and this is color coordinated. So it's just not a polarity device like the single phase ID. This is color coordinated based on the phase. So as you see here, I have a red, yellow, and blue, you know, corresponds with my phasing. So in our demonstration today, we just happen to have blue, white, and red tape. So I attached my blue with the blue tape, the yellow with the white, and the red with the red. So again, it's really easy. Everything's straightforward. You can see what phase is what. The green on here is the ground. Most of the time that is going to be an alligator clip. Some customers have requested additional, you know, ball studs, C-clamps, whatever it may be. Most of the time it is alligators. Okay, so we're going to go ahead and run these devices. And as we're running them, I'm going to use multiple receivers to test for the pulse. We do have what's called a DAVR, which is a digital audible visual receiver. It's going to give us a horn or a beep and a flash of light. So if I'm using the single phase ID, I'll see 1 flash and 1 beep on the cable that I'm looking for. On the 3-phase ID, I'll get 1 flash and 1 beep on the A phase, 2 flashes, 2 beeps on the B phase, 3 flashes, 3 beeps on the C phase. So again, that's a positive ID feature using this. Some people like the analog receiver that we have because this will indicate polarity as it's IDing the phase. Whereas the digital version cannot ID polarity, this device will. So going back to the single phase tool here, I'll get 1 tick to the green, assuming my polarity is correct. So in other words, if I'm using my CT and I accidentally have my CT flip backwards, the tick will be to the red. So it's basically an indicator letting you know, 1, either I have my CT oriented incorrectly, or 2, I could possibly be on the wrong cable, because I can get a return pulse on my concentric. So keep in mind that this polarity check is a really good indicator using the single phase ID and the 3-phase ID. And I'll go in more into the demonstration and talk about it as we go here. But again, this is our 2 receivers, ACDM. So this is our analog current, and this is our digital. I do have 2 different size CTs here. I have our standard and our 6-inch. So some utilities have requested using the 6-inch. So in situations where maybe they're running their underground in 6-inch conduit, and let's say they have all 3 conductors in there, they can actually go around the whole conduit using that 6-inch CT and ID that circuit. So just as an example, we do have a major investor in utility that buys that 6-inch CT, and they go down into a manhole. They have multiple 6-inch conduits in there, and they want to know which conduit I want to cut into, they can go with this CT, go around the conduit until they get all 3 phases on the 3-phase ID. So in other words, they get 1 beep, 2 beep, 3 beeps, and the flashes of light corresponding to that. So they'll know, okay, this is a conduit we need to cut into, and it's a positive ID. We do plan on making a pickup device. In other words, instead of going all the way around the cable, we do plan on making a device where you can actually lay it on the cable. We have had some requests from some customers where they weren't able to put the CT all the way around the cable because either they're in there too tight, they can't move the cable, whatever the case may be. We're going to make a device where you can just lay it right on the cable and positively ID, but we haven't came out with that just quite yet. Okay. All right, so we'll start with a single phase ID, and I have one set up here. I have my black lead attached to my ground, and I always recommend you attach the black directly to the ground rod itself if possible. That way you have a good connection and you're not relying on your concentric bonding. Again, you have to have good bonding when you're using these devices. So connect the black lead directly to the ground rod. My red lead is going through this feed through right here on my elbow. So again, that's a custom made elbow attachment we're making for the single phase ID. So I'm going to go ahead and cut this device on. And the sun was cooperating earlier, but now it's of course in the sun. So I'm going to try to tilt this and get in the shade a little bit so you can see the lights. So as soon as I turn the device on, I have my green pass light. I have my pulse light, you'll see here. It's roughly once a second, very close to it. Okay, so the green light is letting me know I have continuity. So this is a complete circuit. The circuit is not open. Obviously, if the circuit was open, I'd have a red fail light. So now that I have my green pass light, okay, I can go ahead and use a receiver. And for this, I'm going to use my DAVR first. And I have this stood off. This is all de-energized. This was all checked prior to, obviously doing this test. In a case where the CT is put around an energized cable, if the cable has a lot of current on it and this DAVR is turned up, it can squeal quite a bit, and this thing can also slam shut if there's quite a bit of current on there. If that's the case, both these receivers, the DAVR and the ACDM, have a potentiometer on here. You can turn that potentiometer to 0. It works like a shunt. Just leave it there a few seconds and then open the CT back up. Okay, so with that device running, I'm going to orient my CT. I have a red arrow here. I have sender and ground. So my sender is to my left, the ground is to my right. I want to orient that arrow, put it on the cable that I believe it is, and I have a flashing white light. If I turn that all the way down to 0, you'll notice that goes away, and as I just start turning it up, I get that flash of light in the horn. This device does have a locking mechanism on here. I can just push that down and lock it in place. In that case, what that helps, I should say, is that mitigates any issues where if you're fishing this down into a manhole or something like that, or this thing gets bumped, it doesn't get that sensitivity off. Okay, so now that I've ID'd that cable, I'm just going to go through these other cables and check and see if I get a pulse or a beep. Okay, so I'm positively IDing the cable. This is the cable that I'm looking for right here. In scenarios where you may have a long run of cable, I highly recommend you do this at the transmitter. So in other words, I'm going to actually calibrate it based on the distance. So again, if this is a really long cable, this may require some turns, on the potentiometer to get that pulse. So the longer the cable, the higher you're probably going to have to turn this potentiometer. The older the cable, you may have to turn it up a little bit more. So depending on the scenario, you may have to get some adjustment on this cable. This is a really short run in our training yard, so it just takes just a little bit of sensitivity to get this thing to flash and beep. So again, in longer runs, I actually want to calibrate it right at the sender. So in other words, I want to take this CT and put it right here on this red lead, just like that, and calibrate it based on the length of the cable first before I go out to wherever I'm going, because it could be, you know, quite a distance wherever I'm going. Okay, so now let me just show you the ACDM, the difference between the DAVR and the ACDM. And again, some people prefer the ACDM just because you do get that polarity, and the polarity is a nice feature, and I'll show you why here. So again, CT, ground sender, that's oriented incorrectly. I need to flip it around 180 degrees, put it on here. Then I want to adjust my potentiometer on here till I start getting the needle to move. Okay. So I'm gonna turn it up a little bit high just so it's easy to see on the camera. I get a positive deflection. Okay. So again, if I had it oriented incorrectly, I would see that. I would see a hard deflection to the red. So that's a really good indication of, you know, orienting this incorrectly. Or you could have an issue. I'll describe an issue real quick that I was involved in where, you know, we had a red deflection, but it appeared as though that, you know, we had this oriented correctly. And what was happening is that instead of cutting and then terminating the URD cable in the pad mount, it was spooled down into the ground. So they must have had, you know, 20 feet extra or whatever on the spool. It was buried in the dirt and then terminated. So what we were looking at is the spooling effect in the ground. What we thought was the correct orientation ended up, it was the correct cable, but just because of the direction of the cable that was, you know, exposed at the time, it looked as though it was incorrect. So this can get you, you know, solving mysteries sometimes, so to speak, just by the deflection orientation. If I do this on an incorrect cable and have the orientation correctly, you'll see a slight deflection to the red. So that's some current coming back on the concentric of that other cable. So that's a positive ID oriented correctly that is not the right cable. So I have the sender again to my right, ground to my left, and then again if I go to the correct cable, I get a hard deflection to the green. Okay. All right. So that's using the DAVR, the ACDM with the single phase ID, and again works really great, you know, overhead, underground, URD cables, you know, station cables, whatever the case may be, using either receiver, the DAVR or the ACDM. Before we move on, let me demonstrate real quickly that application where if you did not have a center conductor attachment, in other words, I have a complete termination in this switching cabinet and a complete termination on my pad mount over here. I haven't lifted any cables. This could be energized or de-energized. In this scenario, let's pretend it's energized. And what I've done is I've actually taken the single phase ID, attached my black lead to my ground rod, my red lead directly to the concentric. Okay. Now this is working off a theory. So in other words, what I mean by that is you must have a good ground here and you must have a good ground wherever you're going. Okay, so this device will let you know if you do not have a good ground by the way it actually will work. So in other words, if I turn this device on, okay, I get a pass light that's letting me know that I have a complete circuit, and I have a complete circuit just right here. So in other words, my concentric is bonded to the ground rod where my black lead is at. So basically my circuit is complete just right there in front of me. But since I'm attached to this concentric, there is another path to ground. So wherever that concentric is going, assuming the bond is good, that is my other circuit, and I should be able to find that cable. Okay, so it's parallel circuits to ground, basically is what I'm doing. Now the real nice application here is, and I give you an example, I was just at a cooperative in Texas where we're in a subdivision and they didn't know where these cables were going in these pad mounts and junction boxes. They had no idea. Well, I shouldn't say they had no idea. They assumed they knew where they were going, and that they weren't trusting the nomenclature in the cabinets. Using the single phase ID, we just connected to the concentric right here and would see if we had a circuit, and then would ID it in between. So if you think about what's going on, the signal should be less. So you will have to adjust for the loss of signal strength, because I'm losing a lot of signal here on this good ground. Some of my signal is still going away, so I'm going to have to adjust for signal strength going to the other cable. So let's do that real quick. And I'm going to use the ACDM here just so you can get a really good visual of the signal strength being dissipated by most of it being used up on that cabinet there. So I know what cable this is here, okay, because I have it actually taped. It's my white cable, white tape. So I'm just going to go straight to it over here just for sake of demonstration. But if you didn't, I would go through all three cables. But I'm going to put my CT clamp around my cable here. And again, since it's dissipating a lot of current, I have to adjust my pot accordingly. It's kind of a pain with these gloves. Okay, and I probably have to get them to zoom in some, but I'm getting a deflection on slight to the green here because very little current coming this direction. And if I go to my other cables here, assuming I didn't have any tape, I'm going to hold this still. You'll notice a very slight deflection to the red. Okay, so that is not my cable. Again, I have this oriented correctly. In other words, you know, this concentric, it's coming up on the cable, going down here to the ground, so I have to have my CT oriented correctly. My ground is going up that direction, so I have my CT oriented correctly here, and I'm getting a slight deflection to red. So again, that's my incorrect cable. I'm going to go to my last cable here, and I'll hold this up and hold it still, ever so slight to the red. And again, I could turn this pot maybe a little bit more if this wasn't enough for me. At some point, it may not move at all. If it doesn't move at all, it's still the wrong cable, so that's okay. But I'm going to put this one back on the cable that I thought it was, and sure enough, I'm getting a deflection to the green. So again, some utilities are actually using this device or the three-phase ID tool to see if their concentrics are good. So in other words, if this is a direct buried cable that's been here for decades, and maybe you're blowing a lot of arresters or something, and you're assuming, you know, this concentric is bad, good, whatever it may be, I can put this device on here. If I get no pulses, no signal on any of these, then I know my concentric is bad. Okay, so again, I can do that with a single phase ID tool. I can do it with a three-phase ID tool. Okay, I just wanted to demonstrate that real quickly with the single phase ID, just simply because, again, I think that's a really great feature, because we've had utilities ask the question, hey, I've got this cable, you know, I got this cable, I can't take any power out, can't take an outage, You know, we need a way to ID that cable. Well, there's your answer. You don't have to take an outage. You don't have to lift anything. You don't have to ground anything. But again, you do have to have good grounds. You do have to have good bonding in order for this tool to work, or even the three-phase ID tool to work. All right, we're going to talk about the three-phase ID now and demonstrate it some more, where I have it set up just like the single-phase ID on 3 cables using elbow adapters, just like the single-phase ID. And you can use the three-phase ID as a single-phase ID device. Obviously, you can use just one lead. I don't really recommend that, just for the fact that the single-phase ID can be used on single-phase applications or one cable at a time, even if there's stray current. So if you have stray current, you can actually use a single-phase ID, and it pulses on that stray current sine wave on the top of the sine wave. So it works really great on single-phase applications for stray current, whereas, you know, single-phase applications using a three-phase ID doesn't work so great. All right, so the three-phase ID, again, we have this unit here connected. We have the colors matched to the corresponding phases. I've tested my batteries. I've got my grounds on. I tested for de-energized, put my grounds on. Okay, now I'm going to start this tool up and let it ramp up, kind of like the single-phase ID. It takes a few more seconds than the single-phase ID. I'm going to tilt it up just so you can see a little better here. And notice I get the corresponding lights as it pulses. So in other words, when it first started up, let me turn it off real quick because it did it kind of quick. Takes a second. So as it starts pulsing, you'll see the corresponding continuity lights light up. Okay, so there they go. So that's letting me know again that the circuit is complete. And again, it needs roughly 5 ohms or less for those lights to come on. Once it does that, based on what we said with the single phase ID, so in other words, if this is a long run, I want to do all my calibration right here before I go to where I'm going, just simply because I don't want to go there, especially if it's a long ways away, then try to calibrate it. And here I could be calibrating on either the wrong cable, you know, I could be calibrating on who knows what. So just to simplify it, get it right, do all your calibration right here. And again, once you've got that set up and set, you can lock it down. So let me grab the DAVR and we'll do the calibration right here. And again, these are short runs in our training yard. So it's super sensitive. Make sure I have my orientation correct. My ground, my sender. So my ground is up, going to the feed through, going out the cable. So I have my orientation correct. And evidently this one was already turned up. I'm going to set this one back to 0, just so we start there. So that's 0. I just want to start turning it, which is very little. Obviously, again, because it's short run, lock that in place. And notice 3 beeps, 3 flashes of light. So I'm not just positively IDing the cable, I'm IDing which phase it is. So that's my B phase. Put it around my, my C phase. I put it around my B phase. I get 2 beeps, 2 flashes of light. And let me say that again. 3 beeps, 3 flashes of light. That's my C phase. And 1 beep, 1 flash of light. That's my A phase. So in a situation where if I was using the 6-inch CT clamp, and let's pretend this was in a PVC pipe, I would get all 3. So I'd hear my A, my B, and my C. Okay, so that would be the situation where I had a 6-inch CT. So now if I'm going where I'm going, which is just right here, and I orient this correctly, so in other words, my sender's to my right, grounds are to my left, start putting it around cables, nothing. And this one, I get 3. And let's pretend I didn't have that blue tape on there. I can positively ID that phase. So in a scenario where, okay, if I'm splicing into this C phase, I'm gonna put a single phase load on it, let's say. I positively ID this phase. Now I can cut it, splice into it. I get 2 beeps, that's my B phase. 1 beep, that's my A phase. And again, I can encapsulate all 3 of these. And what's happening here? Why did that go away? So even if I turn this up, but if I turn it down to where it was at, it muted, so I actually have to turn it up some. What I'm determining, or what I'm noticing, again, you have to become familiar with the tool a little bit, is that I'm getting return current on those concentrics. It actually muted this device, okay? Now, if this device would have went totally mute, no matter where I adjusted it, even if I turned it up and it was still muted, it's letting me know that that ground or bonding on the grounded end is no good, okay? So as we did with the single phase ID to some degree, this tool will do the same thing. It lets you know if your grounding or bonds are no good. So in other words, I'm sending 100% of my current pulse down the center conductor, as you can see through the elbows. That means 100% is coming back on the concentrics and muting the tool. That ground is no good. And I've actually demonstrated this on our riser pull, because our riser pull over here, the ground is actually no good on that. And if I put a parallel ground to earth on that riser pole, then it actually works. So, you know, this is a really good indicator. Now, if I wanted to do this check before I left from when I calibrated it, I can do that. What I would have to do is I would have to encapsulate all 3 of those primary cables in this CT and do the check right there. So in other words, if I get the pulse on each 3 individual cables doing the calibration, and then I encapsulate, if I can, all 3 before they go into the dirt right there, and it goes away, that means my bonding or my concentric is no good, my grounds. Okay, so let's use the ACDM here and get a really good visual on the polarity of using the tool. Okay, get this glove on. So again, ground sender, I want to rotate that 180, put it on what I think is a good cable. And I still have this turned up quite a bit from my last test over there. And notice what I see on here. And again, a lot of people really like this because it is a really good visual. So in other words, I see all 3 phases. Whereas using the DAVR, I just got 1 phase. I just got whatever phase it was. Using this device, I can actually see the 2 incorrect phases and the correct phase. So I'm actually getting a really hard positive green on the correct phase, which is 3 pulses. And I get 1 pulse and 2 pulses on the A and B. So that's a really nice feature. If I put it on what I think is B, I get 2 hard pulses, and I get the A and C on that, incorrect, okay? And I put it on what I think is A phase, I get a really hard pulse to the green, one pulse to the green, and my other B and C to the red, okay? So even through the process of elimination, if I did orient this incorrectly, I would get a really hard pulse on the correct phase incorrectly. So you'll notice my really hard pulses are to the red now. So I know this is the phase that I'm looking for, but my orientation is incorrect. So all I have to do is just spin it around. So for whatever reason, if you got confused, you know, going into a manhole, maybe you have bad direction abilities or something, you can determine which phase it is, okay? All right, so I just want to demonstrate also one of the features using this three-phase ID, and I'm going to let Brent be the guinea pig on this test. I'm going to get him to lift a ground on a phase. He's not going to tell me what phase it is. And again, a lot of utilities are using this tool for this reason. But he's going to lift that ground, and we're going to be able to tell by the machine which phase it is, just by the corresponding continuity lights. So he's kind of old, he moves kind of slow. We're going to get him to do that. Here, leave the camera. We don't want to watch Brent. He's kind of decrepit. Okay, so he lifted the ground, it's C phase. All right, so if we were doing this legitimately and he would call, you know, let's say he's several blocks away and, you know, he said he's going to lift the, you know, ground on C phase, and he did that, I can stand here and watch this. That continuity light goes out. I can verify back to him, phone, radio, whatever, say, hey, yeah, okay, you lifted the correct ground. So that's a really nice feature with the tool. And again, utilities are using this as what's called a soft ground check. And even a situation where, you know, maybe this primary cable, for whatever reason, is damaged and they think it's grounded, again, you can put this tool on here just to verify to see if it's grounded. It's not a high impulse test. It's not like a thumper or anything like that, but it does work as a good passive ground test.